Hello students, welcome back. Let us resume our discussion in section 2. Previously, we studied the graph of sine function. That's a basic shape. And then, remember this animation? That's how the graph of sine function was deduced from the definition of the sine function. Left-hand side circle diagram, the unit circle picture, gives you the definition of the sine function. And in the right-hand side, you're looking at the graph of the sine function. And the verticals precisely match. And the arc length must match the horizontal. I hope everybody remembers that. And then some further properties of sine. Now, let's do the same for cosine function. And a lot of the ideas are going to be pretty much the same. So if you handle cosine function okay, I said it backward, excuse me. If you understood sine function okay, then cosine will be much easier to follow. Always, the very first is the hardest. And the repetition is that much easier. Okay, here we go. Here's the graph of the cosine function. What do you see? Another wave pattern going up and down, up and down, up and down. Wave function with periods 2 pi, of course. But the main difference is the starting point. Starting point, or starting phase, is the maximum here. What do you mean by the phase? Typically, we call theta as the angle. Starting angle is phase, or you use the term phase shift or those kind of terms. I don't want to go through with the precise definition, but the term phase is being used here and there, so maybe it's useful to remember those. But if you're not really interested in the wave theory, especially application in physics or electric engineering, then never mind about phase. I don't want to go too deeply into the precise definition, but in case there are some students who are interested, I'm using that kind of term. So starting phase is at the maximum here. And as for the definition, well, let's look at this unit circle picture. And then the arc length here is the arc length is equivalent to theta because the radius is 1 in this case. And that's represented as blue. So in this theta f theta plane, in this graph, horizontal is theta, and then in this definition of cosine function, in this unit circle picture, theta is equal to the arc length s, because the radius is 1. As for cosine, that's x over r, but r is 1 in this case, so it's just x, and that is represented as green in this picture. So this horizontal must match this vertical here. So compare with the graph of sine function, it's a bit tricky because I have to tilt this horizontal versus that vertical. But otherwise, it's the same idea. So I hope this animation here will not cause too much difficulty to anybody. We already saw the sine function. Okay, there's the animation. And then the horizontal in your left and the vertical in your right must precisely match. Left-hand side, the unit circle picture, is a definition of the cosine function. And then in the right-hand side, we have the graph of cosine function. So, starting from the first quadrant, I'm moving to the right, so x is positive. Oh, let's begin with 0, and that's when x horizontal is at maximum. So we begin with maximum function value 1, and decrease, decrease, decrease. Well, x is still positive, so function value is positive there, and hitting 0 here, and then go further to negative to the second quadrant. X is now negative, and getting more and more negative, minimum -1, and then now getting less and less and less negative. This horizontal and that vertical must match. And now back to positive. That's the graph of cosine function associated to the graph of, the definition of cosine function. Now, one more. What's the relationship between sine and cosine? If you look at the graph, what do you see? Essentially the same shape, except for the starting phase, right? So, are they related from the definition? Well, the answer is yes, indeed. Yes, indeed. Let's go to the drawing mode and then consider shifting this picture to counterclockwise 90 degrees. So we have something like this. So okay, we have this picture here that is gonna be right triangle is gonna be shifted like this. And then let's see, the sector is gonna be shifted like this. If you take the 90-degree shift, rotate pi/2 in the positive direction, that is counterclockwise. Am I making sense? Now pay particular attention to this x-coordinate, horizontal. That gives you the graph of the cosine function, right? X over r, but r is 1, so cosine value is just x. Now let's take a look at the rotated triangle here, and that's precisely matches this vertical. So if you take this pi/2 rotation, then this horizontal x, which gives you cosine, will precisely match this vertical y, that'll give you sine. So if you just take 90-degree rotation, cosine becomes sine. Let's go back to the original mode. Let's get out of the drawing mode, And then open up the graph of cosine function and also the graph of sine function and compare them. Same shape, going up and down, up and down, up and down, same wave pattern and same period 2 pi, exactly the same except for the starting phase. Why? We just answered. Just tilt 90 degrees, just take a rotation of pi/2, so change the starting phase, then cosine becomes sine, precisely. So the shape of the graph must be identical. The only change is the starting phase. Anyway, let's go ahead with the animation, and then we have the graph of cosine function. It's a bit harder to see compared with sine function because here in the definition we have horizontal. Here in the graph we have to look at vertical. Previously for sine, both were vertical, so they precisely matched. It was easy to see. A little bit harder, but otherwise pretty much okay. And then here is It's the same thing, moving from negative pi to positive pi. And then you can see the graph of cosine function is symmetric with respect to the vertical axis. So it's an even function. You can deduce cosine of negative of theta is just cosine of theta. So from the origin to the right by theta, to the left by same theta amount, same y-coordinate value, same function value. It's an even function. And then here are some further properties of cosine. All those come from the graph of cosine function. Again, I'm not going to deduce these formulas. I'm going to do those in lesson 9 when we have to prove trigonometric identities seriously. For now, let us just get these from the behavior of the graph. Cosine function is bounded between -1 and +1 here. Cosine of 0 is maximum 1. Cosine of pi over 2 is 0. Cosine of pi is minimum -1 right here. And cosine of 3 pi over 2 is 0. And cosine of 2 pi come back to the maximum 1. Period is 2 pi, so plus minus 2 pi doesn't change anything. Plus or minus pi, we have negative. So instead of upward here, going exactly same downward, and then another plus pi going upward here, another plus pi going downward here. And then we already saw the symmetry with respect to the vertical axis is an even function. And then this one here, well, sine of pi minus theta was just theta. Remember this? But for cosine, it is negatives. So we don't have the same symmetry with respect to x equals to pi over 2, or, alright, the vertical line. Instead, we're gonna be using this one more closely than that one. What am I talking about? Pay attention to this. Cosine of theta is, for example, some y naught. Then what do you mean by that? Theta is inverse cosine of course, y naught. And for sine, pi minus of that was automatically the answer, but thanks to this, negative of that is automatically the answer. So you can combine these two as plus or minus. Why do we have this kind of behavior? Well, let me show you. Let's go to the drawing mode. Alright, let's suppose we have a vertical line like this. Okay, previously for sine, we drew something above the x-axis, so I'm doing opposite this time. I could have done positive y naught. So we have this. We have inverse cosine, but we have another one here. Negative of that is automatically an answer too. And the reason is because of the symmetry with respect to this vertical axis, y-axis. And then reason is this one. Okay, let's get out of the drawing mode. We'll come back and discuss more of this when we study inverse trigonometric functions. Otherwise, pretty much the same as sine. Alright, so much for properties, and so much for the cosine function.